Okay, now we are on section 3, periodic table and bonding. Okay, so here we have, again, bold information. We're going to go straight to the questions. And here we need to complete for a missing product. Okay, so I am going to make a list for this one. So you can see I have Na, I have H, and I have O. So I should have the same elements on the other side, right? On this side, I have 2 Nas, 2 H's in here, and 2 of them, so that's 4, and then 2 O's. On the other side, I have 2 Nas, that's good. I have only 2 O's and 2 H's. So, what am I missing? This is not balanced. So what am I missing? 2 H's. But when I write 2 H's, I have to write it like this because it is a diatomic molecule. So when I do this one, what do I have? I have F, E, and Cl, right? Fe, I have 2, and I have 6. On this side, I have 2, and I have no Cl's. So I need 6, but you see this 3 in front? Okay. So I need 6 total, so it means it ends up being written like this, because 3 times 2 would give me 6. Name an element that exists as monatomic molecules. So I need a noble gas. So anything that is a noble gas. Neon, argon, krypton, xenon. Right? So neon, as an example. Now, what is the electron configuration of a K+1 ion? So first, let's figure out the electron configuration of K, which is 2881. So 2881. Now, if it's K+1, that means it loses 1 electron. Which electron is it going to lose? Its valence electron. So this one is gone. So this is what's left, and that's the electron configuration of the K+1 ion. A Ca+2 ion has the same electron configuration as which noble gas? Well, first let's look up Ca. It's 2882. Okay, it's +2, that means it loses 2 electrons. Which 2? These 2 valence electrons. So what's left is this. And which noble gas has that electron configuration? It is argon. When Fe forms a +2 ion, its radius what? Well, when it loses electrons, its radius decreases. Draw the electron dot diagram for Li +1. Okay, so here is, so Li, let's just look at Li again. Li's electron configuration is 2-1. It normally has 1 valence electron, so its Lewis dot diagram would look like this, right? But it loses this valence electron to become a positive charge. So when I do it, it just looks like this. That's it, with no dots, because it lost its valence electron. All right, now let's move on. What is the electron configuration of a Cl-1 ion? So let's go to Cl287. Now it's a Cl+-1 ion, a Cl-1 ion, which means it gained an electron. It means it gained a valence electron. So it's not this, it's 288. Okay. An S-2 ion has the same electron configuration as which noble gas? So S is 286. It is -2, which means it gained 2 valence electrons, so it became 288. And we already looked that up before. That's argon. When O forms a -2 ion, its radius will increase. It gains electrons. Draw the electron dot diagram for F-1. So F is 2-7. Okay. When it becomes a -1 ion, it is no longer 2,7, it is 2,8, right? It gained a valence electron. So it should look like this, still in brackets with the charge outside. Which molecule has the strongest hydrogen bond attraction? Hydrogen bonds form between obviously hydrogen and 3 specific elements, N, O, and F. If it's not one of those, ignore it, okay? So this is not, so I can ignore those two. Now I have H with O and I have H with F. So which would have the stronger hydrogen bond? It would have a stronger electronegativity difference. So hydrogen is 2.2 and oxygen is 3.4 and fluorine is 4.0. So which one would have the stronger hydrogen bond? It would be this one, because the difference between 4.0 and 2.2 is greater than the difference between 3.2 and 2.2. All right, which compound has the greatest ionic character? Okay, meaning the greatest difference, right? So Na is 0.9. So that's going to be the same for all of them, right? And I want to find the difference that's the biggest. So let's just look. We have Br, right? Br 3.0. I, it's all the way down here, 2.7. Cl 3.2 and F 4.0. So which will have the biggest difference? Right there. Okay. All right. Which element on the periodic table is a non-metallic liquid at STP? All right. Only 2 liquids on the periodic table at STP. Now you could memorize them, which I do, which is Hg and Br. Also, if you remember, STP is 273 Kelvin, right? And we could use this magic right here, table S. Melting is going from solid to liquid. Boiling is going from liquid to gas. So anything here is a solid when we're comparing temperatures. So if the temperature is less than this, it's a solid. Between it, it's a liquid, and greater than this, it's a gas. So if I start looking for where would 273 be between, it's not between any of these. Could be, nope, because 273 it would be over here. So I keep going. Ooh, look right here. Here's one right here. Okay, and then I could continue doing the same thing, keep going, oh, right here. So yes, I could memorize it, but there's another way to get there. But all I want to know is which one is non-metallic. Well, on the periodic table, you should remember non-metals, metals. So the non-metallic one is Br. Which element at STP is a liquid that conducts electricity? That means it's a metal, so that's Hg. Name an element that exists in a crystal lattice at STP. So what does that mean? Well, that means that it is a solid. Okay, this literally means it's a solid. So you could pick anything that's a solid. So your list is giant, right? So you could say cobalt, you could say beryllium, you could say carbon, you could say aluminum. So let's just say carbon. Name an element that has no definite volume or shape. So this is a gas. So here are my options for gas. Hydrogen, all of the noble gases, and then this little NOFCl. Okay, so if I'm going to say O, I could say O2. If I want to write it in words, then I don't have to worry about the 2. All right, but that's up to you. Which element, when bonded with O, will form a partially negative end of a polar covalent bond? Okay, if it is the partially negative side, then it is more electronegative. So an easy element to pick because it has the biggest electronegativity would be fluorine, right? Which element has the greatest attraction to electrons when bonded to Na? So all this means is which has the biggest electronegativity. All right, so I can just look them up. NOS. I know it's not going to be Al because that's a metal, right? But look up NO and S. O is bigger than N, so it's definitely O. In the molecule CH3Cl, which element represents the partially negative end of the molecule? So if I have CH3Cl, this is what I have, right? So I have C bonded to H and C bonded to Cl. So let's look at these two bonds, all right? So C is 2.6, H is 2.2, and Cl is 3.2. So this gives me a difference of 0.4, which is nonpolar. But this gives me a difference of 0.6, right? Which is polar. And the Cl is bigger, so it pulls. So there. Now, if these were spread evenly, like if I had two Cl's and they could be spread evenly, then it would be a nonpolar molecule. 4 elements are heated at the same rate, which will lose an electron first. So that is ionization energy. And I'm just doing, so if I want to know which one will lose an electron first, I want a low ionization energy. So sodium is 496. Bromine, 1140. So far that one loses. Fe, 762. And Ca, 590. So which will lose an electron first? This one, because it takes the lowest amount of energy. And which of the following compounds contains both ionic and covalent bonds? What this means is it has a polyatomic ion. Because a polyatomic ion has covalent bonds, but it's also an ion. So then it is attracted to something else and forms an ionic bond. So all you have to do is look for the thing that has something from table E, right? So you just start looking at table E, comparing it to the compounds, which one has one, and there we go. So that is the end of section 3.